All right, guys, welcome to Spiral Review number 2. This is for 8th grade, and I'm going to go ahead and just kick it off for us. The first part of this spiral review is on solutions to equations. So most of the time you're used to having equations get x equals a number, right? Well, that's just one solution. Sometimes there are weird situations where you could plug in any number for the variable, and the left side would simplify to equal the right side of the equation, meaning it would be true in any possible case. Other times you'll get a situation like 7 equals 3, and that's not even possible. That's no solution. So I gave you some quick examples at the top. If you have the same amount of x's, but then the same amount of constants, it doesn't matter what number you plug in there for x, you could get any number. If you're gonna multiply it by 7 and then add 3, and over here you're gonna take that same number, multiply it by 7 and add 3, you're gonna get the same conclusion, right? It's going to be this left side equaling the right side. There's infinitely many possibilities, IMS, right? We talked about in class that will allow you to plug in a value for x there, okay? So conversely, when it's not possible, is let's say you take a number multiplied by 7 and add 3, and you take that same number multiplied by 7, but now you're going to add 5. Okay, that's impossible. You can't do that and still end up with the same number. Remember, equations are just telling us, hey, this left side equals the right side. Let's simplify it, okay? So if you get something like your same x's, but then your constants are different, that is not gonna have any solution. There's no number I could plug in there that would work. And finally, just one solution is if you have a different amount of x's, you don't even actually have to look at your constants. You know that you're gonna have just one solution. So if you get to the point where you simplify your answer down to these 3 sorts of scenarios where you have x's and constants, then compare. And you could rearrange the x's and constants, like if your constant came first, you could put it after your x's, and that might help you see. So in this first example here, I've got negative 3x plus 15. That's already as simple as possible, as we've got our x's and our constants right there. And then I want to do the distribution property. I want to go ahead and multiply 3 times 5 and 3 times negative x. That's like our waitress. We talk about that in class. She's taking water to each person at the table. 3 times 5 is 15. And 3 times negative x is negative 3x. So 3x plus 15, just so it's still hanging out on the left. And you might say, well, Mrs. Landers, that looks a little bit different, but it's the same thing. Our constants are 15, a positive 15, and our x's, we have a negative 3x and a negative 3x. So this is gonna have infinitely many solutions because I could switch the order there and still have the same amount of x's, the same amount of constants. I'm multiplying by negative 3 and I'm adding 15. So no matter what I put in there, I'm doing the same thing each time on the left and the right. So that one has infinitely many solutions. So we write an IMS, okay? Just make sure on numbers 2 and 3, go through with your waitress. 1/2 of 4x, half of 4 is 2, right? So 2x, half of 14 is positive 7, okay? And see how that works out when you use your waitress over here on the right. And look at your possibilities, look at those models up above. And down here, the only thing I want to point out is there was a little x that got cut off right at the end because the copy machine, my nemesis some days, okay? So watch that. Combine like terms. You don't have to do the waitress over here, but you do have to combine those like terms to make a distinction, okay? Oh, I gotta stand up and turn my lights on. Okay. I sometimes feel like a crazy person when I do stuff like that. Doesn't take much. Okay, the next 2 questions are drawing a line from the equation. So on our last one, our last spiral review, excuse me, we had the line drawn for us and we had to write the equation. Well, now we have the equation, we have to draw a line. So it's pretty easy. Our starting point, our sneaky pirate, tells us to start at the -1, only on our y-axis. Okay, that's our starting point, down 1 from our origin. And then from there, our slope tells us what to do. We're going to go down 2 and we're going to go over 1. Okay, left dot elevator run. So we're going to go left from the left, we're going to move to the right. So we have to go down 2 and over 1, down 2 over 1. Now you could do the opposite. You could go up and to the left, up and to the left, but it's a good thing to get to a consistent habit of doing it the same way every time. Okay, so then you can draw your line. Okay, and see different points on that line itself, okay? So start with your starting point, hidden at the back by that sneaky pirate, and then do left dot elevator run. Put it in fraction form if that helps you. Okay, next up on the front of this page is, it says, use a calculator to write the fraction in decimal form. Round to the nearest hundredth. So what do you notice? Okay, so the first one is 4/9, and I can just go ahead and put that on my calculator. Literally, guys, 4/9 is just a little baby division problem, okay? 4 divided by 9 is 0.4 repeating, okay? So I don't want to put that forever, so that's why I told you to round, okay? Round to the nearest hundredth. So I'm going to underline my hundredths place, okay? And I'm going to look to the right, and if it's 5 or more, I'm going to up my score. If it's 4 or less, I'm going to let it rest. Well, it's 4 or less, so I'm just going to let that rest at 0.44. That's the nearest hundredth, okay? Then on your calculator, do 31 divided by 99. And then on your calculator, do 8 divided by, sorry, for number 8, do 523 divided by 999. And then tell me what you notice. Look for something. Look for patterns. In math, we're always looking for patterns. How can we do things better? How can we do things faster? And that's usually going to get you your homework done faster too. All right, this next question, or this next section, has lots of rotations, okay? Really important skill to have down. I've given you some cheat sheet stuff here on the side, like I tend to do, because in real life, if you can reference information and then give or solve a problem, that's really important. So we're going to rotate the images and write the coordinates. So the original coordinates, okay, on this first one, let's just take this triangle right here, A, B, and C, okay? So A is at 1, 0. B, go in order, is at 2, 1, 2, 3, 4. So 2, 4, and C is at 4, 1. Okay, so you could go in right away and put the first original coordinates of our pre-image before we move it, translate it, flip it, turn it, all sorts of crazy stuff. Okay, write your coordinates. You can get all that done. Okay, when we do rotations, we have some things happening. We could do 1 turn to the right. Okay, for me, this is my right, 1 turn to the right, and then 3 turns to the left matches up. They're the same thing, they end in the same spot. So that's why the directions are the same. 1 turn to the right clockwise, or 270 degrees counterclockwise. 2 turns to the right is the same as 2 turns to the left. So right, right, points down, right, right, sorry, left, left, points down, and they end in the same spot. And then also 3 turns to the right is the same as 1 turn to the left, okay? So then we have some clues here on what we need to do. And we have to pay attention to our directions. So this first one says rotate 90 degrees counterclockwise. So I'm going to find very carefully which one says 90 degrees counterclockwise. And it is, boom, this one, okay? Not 90 degrees clockwise, totally different. 90 degrees counterclockwise. You just switch your X and your Y coordinate and then change the front sign. Pretty easy, okay? Now, switching X and Y, so 0, 1, okay, becomes 1, 0, or sorry, 1, 0 becomes 0, 1. And we have to change the front sign. Well, 0 doesn't have a sign, so that's all I need to do. I can just keep it 0. And then the next thing is 2, 4. So I'm going to switch them, change the front sign. So 2, 4 becomes 4, 2, and I got to make it a negative 4. Last one, 4, 1. I'm going to make it 1, 4, change that to a negative 1. Okay, now I've got my primes, my A prime, B prime, C prime. So I'm going to go 0, 1. I'm going to go negative 4, 2. Make sure I got that right. Okay, negative 4, 2, and negative 1, 4. Make sure you go up when it's positive on that one. Okay, so then you just connect them. I'm going to have to do it for a second so I can connect them decently. And if you're not sure what goes where, just remember, okay, you've got your coordinates written down, but A prime was at 0, 1. B prime was negative 4, 2, and C prime was at negative 1, 4, okay? And it should make sense. If you're doing a 90 degrees clockwise turn, doing 1 turn to the left, if you're in the upper right-hand quadrant, you're gonna turn 1 quadrant over to the left. So imagine just turning your page, rotating your page. I find that the visuals can get hard when you're like twisting and turning pages. So if you remember the tricks for flip-flopping all those numbers and signs around, you'll know what to do. Okay, so take that and just pay attention. We're going to rotate 180 degrees clockwise here. So just follow the directions, keep your X and your Y right where they are, but just change both your signs. Okay, the next one says rotate 90 degrees clockwise. So that's actually the first one. Switch your X and your Y, but then change the back sign, not the front sign like we did earlier. It's a different move. And then rotate 270 counterclockwise. Look, that looks familiar, right? 270 counterclockwise, switch X and Y, change the back sign. Write down all those coordinates as you're working, okay? All right, last but not least, application. So taking the things that we've learned and helping make a little more sense of the world, because a lot of times there's problems in the world that we have to solve, like construction, architecture, all sorts of things. And it's important to be able to apply things that we've learned, okay? All right, so this one says the perimeter of the rectangle is equal to the perimeter of the square. Ooh, perimeter. All right, remember I talked about Perry the platypus in class? He walks around the pool. Perry the platypus, Perry means around. So the distance around that rectangle is equal to the distance around the square. So if I take all the sides and I add them up of this rectangle and I take all the sides of the square and I add them up, they're going to be equal to one another. So what I'm going to do is I'm going to write an equation. I know, crazy, right? So if I know that this side is 4x plus 2, I know that the other side is 4x plus 2. If I know that this is 2x, then I know that's 2x. So if I have 4x plus 2 plus another 4x plus 2 plus 2x plus 2x, oh my goodness gracious, that's a lot, but that's all the sides. If I add up all that stuff, that's the perimeter of my rectangle. All of that is equal to the square, which is 3x plus 1, 3x plus 1, 5x minus 3, 5x minus 3. We're combining all those. Even though there's a subtraction sign, it's still representing a distance. 3x plus 1 plus 3x plus 1 plus 5x minus 3, or like a negative 3 plus 5x minus 3. So think about all those things. Woo, look at that. That's crazy. Okay, don't worry though. You guys got this. Just combine like terms, okay? I've got 4x's, 4x's, 2x's, 2x's. So all together, that's 12x's. And then I've got my constants, positive 2 and positive 2. That's just 4. So that wasn't too bad, right? We really made that side look way more simple, didn't we? On the other side, we got 3x's, 3x's, 5x's, and 5x's. Altogether, that's 16x's. Now be careful on this because we have some sign changes. I've got positive 1 and positive 1, that's 2. Negative 3, negative 3. Ooh, I'm taking away 6 right there. So positive 2 and negative 6 is a negative 4. And then I'm not going to tell you any more, okay? Because now I want you to go through and solve for x. Once you know x, you plug it back into any of these values, or to these values, either here on the rectangle or here on the x, or sorry, the square. And you can figure out the perimeter of one. Once you figure out the perimeter of one, it's just going to tell you the perimeter of the other. So plug in those values here. So say once we figure out x, should be a nice neat whole number, double that. 2 times that number is going to be this measurement. 4 times that number plus 2 is going to be that measurement, and so on. And you fill in those as well for the square. Okay. All right, that's it for me today. Good luck. Let me know if you have any questions.